Hello everyone! For this particular lecture video, we'll be having the second installment for the topic gases. For the lesson objectives, we'll be having number 1, use the ideal gas equation to express pressure, volume, temperature, and amount of gas under certain conditions. Second, express the gas laws into a combined gas law equation. And then third, describe gas pressures through Dalton's law of partial pressures. For the topic outline, we'll be having ideal gas law, combined gas law, and your Dalton's law of partial pressure. Again, apologies should you be hearing some ambient noises or along the way you'll be hearing some unnecessary noises, but nonetheless, let me continue and let's just focus in the content. Okay? Let's start by defining what an ideal gas is. An ideal gas is a hypothetical gas that satisfies or follows all assumptions of the kinetic molecular theory. Moreover, the ideal gas molecules have no intermolecular forces of attraction. Thus, their volume is negligible compared with the container's volume. Now, the ideal gas equation is actually a combination of your Boyle's law, Charles' law, and Avogadro's law equation, particularly their relationship, okay? The relationships of volume with that of pressure, volume and temperature, and volume and number of moles. So the first one is the relationship volume is inversely proportional with pressure. This is actually your Boyle's law, okay? Your second relationship is actually volume is directly proportional with temperature. This is actually your Charles law. And then the third one is that volume is directly proportional with the number of moles. This is your Avogadro's law. Okay? Now, if we combine all of these relationships, we can have volume, again, is just simply directly proportional with number of moles, and then temperature, and then volume is inversely proportional with your pressure. Okay, so we have this particular relationship. Now simplifying the relationship, we can now write volume is equal to NT all over pressure multiplied with a constant K. Since we are simplifying the inverse relationship and even the direct relationship, we can turn it into an equality. So we will be having a constant. Now this particular constant is actually your R, or what we call the gas constant. Now the gas constant would embody how an ideal equation satisfies all the assumptions of your kinetic molecular theory. So I can simply write this further into V is equal to nRT all over pressure. Now to make the equation much simpler, I will be multiplying both sides of the equation by pressure so that I will remove the fraction. Okay, the fraction here on the right side. So multiplying both sides by pressure, so pressure here will be cancelled. We shall have PV is equal to nRT, and this shall be our main equation for the ideal gas equation. Okay? Okay, so I hope you understand how the ideal gas equation was brought about by combining your Boyle's law, Charles' law, and Avogadro's law. Okay? Okay. Now, R again is called the gas constant. Now, your R is actually, since it is a constant, it has the value 0.0821 liter atmosphere all over mole Kelvin. So that is the unit for your R. And this is the value 0.0821 with the unit liter atmosphere all over mole Kelvin. Now, there are times in a ideal gas equation problem or sample problem, it will undergo, or the gas that is of focus will be undergoing an STP condition, meaning to say standard temperature and pressure. So meaning to say your pressure shall be 1 atmosphere, your temperature being standard is 0 degrees Celsius or 273 Kelvin, And then for the number of mole is that 1 mole of an ideal gas can occupy 22.4 liter. Now, how is that, or ano po ang dahilan bakit 0.0821 ang gas constant? Bakit nag-come up sa ganitong value? Because of this one. Okay? So, using our main equation, PV is equal to nRT at STP conditions, okay? Under STP. So, kindly solve for R. So, divide both sides by NT. We will be having the equation R is equal to PV over NT. So, since to solve for R, we are under STP conditions, my pressure shall be 1 atmosphere. My volume shall be 22.4 liters according to the slide. And then the number of mole will be 1 mole multiplied by standard temperature, that is your absolute temperature Kelvin, 273 Kelvin. So input this one in your calculator, you shall have the value 0.0821 liter atmosphere all over mole Kelvin. So this is how the value or the constant value for the gas constant came about. Okay, using the main equation for your ideal gas equation, and then solve for R under STP conditions. Okay. Okay, so I hope you understand how this particular slide shows you how the ideal gas equation came about, as well as the value for your gas constant. So again, this slide will just show you the standard temperature pressure values. Your R is 0.0821 liter atmosphere per mole Kelvin. Your pressure is, again, STP is 1 atmosphere, but still I just want to include in the slide the conversion factors for your atmosphere to millimeters mercury, atmosphere to torr, atmosphere to Pascal, atmosphere to kilopascal, and then atmosphere to PSI. Okay, so but then again, your STP for pressure is 1 atmosphere. And then temperature, 273 Kelvin, absolute temperature, do not forget that. And then volume is 22.4 liter. Okay? Okay, we'll be using these values later on. Let me provide an example applying the ideal gas equation. Okay, so example number 1. So read the problem. How many moles of gas occupy 98 liters at a pressure of 2.8 atmosphere and a temperature of 292 Kelvin? So the given are volume, pressure, temperature 292 Kelvin, and do not forget your R, which is 0.0821 liter atmosphere per mole Kelvin. The one required to be solved is mole. Okay? N, and the unit is mole. And then the equation is PV is equal to nRT. Since N is the one required to solve, so derive an equation for number of moles. So divide both sides by RT. We shall have the equation N is equal to PV all over RT. Okay? Now double check your given if they are appropriate. So since your gas constant has the following unit, L or liter, so your volume must be in liter. So check. Since your gas constant has the unit atmosphere and this needs to be cancelled, your pressure should be in atmosphere. So no problem, your pressure is in the unit atmosphere. Same thing with your temperature. Your Kelvin here in R or the gas constant should be cancelled. So your temperature should be in Kelvin. So indeed, this is Kelvin, so everything's okay. So substitute. So pressure is 2.8 atmosphere multiplied by 98 liters all over your R. R is 0.0821 liter atmosphere per mole Kelvin multiplied by 292 Kelvin. Show the cancellation. Kelvin is cancelled. Liters is cancelled. Atmosphere is also cancelled. The remaining unit is mole. So input in the calculator. So this will be 2.8 times 98 all over 0.0821 times 292. Okay, so this is the answer. So since the last operation used was division, we shall ascribe to least significant figure. Okay, least significant figure among the given. So the least significant figure, so let us count the significant figures. This is 2SF, 2SF, and this is 3SF. So R is constant, so it's not a candidate. So the least SF is 2. So I will round off my final answer up to 2 significant figure rather. So my answer is 11 moles. Okay? So that is how we use or solve using the ideal gas equation. Okay? Okay. At this point, I'll be discussing or showing or show everyone some of the derivative equation from the ideal gas. We can also use the ideal gas equation in calculating the density and molar mass of an ideal gas. So from the PV is equal to nRT, there are derivations that we can get from that equation. Using the ideal gas, we can solve for the density using pressure times molar mass all over RT. And then for your molar mass, that will be dRT all over pressure. D being the pressure, R being the constant, T as temperature, P as pressure. And then on the other hand, you have your P as pressure, M as molar mass, R as gas constant, and then T as temperature. Example. At what pressure will a sample of helium have a density of 0.112 gram per liter at 27 degrees Celsius? So let me write the given. So the given are the following. So we have your density, 0.112 gram per liter. And then we have temperature, 27 degrees Celsius. And then, okay, let's proceed with the required. So required here is pressure. So the pressure must be in atmosphere. Okay, equation. Now, since we're dealing with density, or we have the given density, I may use the equation D is equal to PM all over RT. So create an equation for pressure, since pressure is the one required. Okay, so I can simply derive an equation for pressure by simply multiply both sides by RT and then divide both sides by first let me just multiply both multiply both sides by RT, so RT will be cancelled. I shall have dRT is equal to PM, and then at this point I still have M with pressure, so I need to divide both sides by molar mass, so I have this one. So molar mass will be cancelled. I shall have the equation P is equal to dRT all over molar mass. So I shall use this particular equation. Okay? So double check all of the givens. Your density is provided. So check. Your R, that is constant. So do not forget that one. So R is 0.0821 liter atmosphere all over mole Kelvin. How about temperature? Your temperature should be in Kelvin. So I must add 273 here. 27 plus 27 plus 273. I shall have 300. So this must be 300 Kelvin. So I have my Kelvin already here. How about molar mass? So molar mass is another given. So where will we get molar mass? As we look at the problem, there is a mention of a sample being helium gas. So helium will be the source for your molar mass value. So look for the molar mass of helium in your periodic table. So helium is this one. So I'll be getting up to 2 decimal places. So that will be 4.00 grams per mole. So all of my given are now provided. I may now proceed with the solution. Okay, so let me just zoom out. Okay, solution. So P is equal to dRT all over M. Substitute. My density is 0.112 grams per liter. multiplied by R, 0.0821 liter atmosphere all over mole Kelvin, multiplied by the temperature in Kelvin, 300 Kelvin, all over molar mass. My molar mass is the helium's value, 4.00 gram per mole. Show the cancellation. Grams is cancelled. Liters is also cancelled. Mole is cancelled. And then Kelvin is cancelled. The remaining unit is atmosphere, which is the one that we are required to solve for. So input the following in your calculator. 0.112 times 0.0821 times 300 all over 4.00. I shall have this answer. So now, look at the given for the least SF. So we have here 3 significant figure. Your 27 is 2 significant figure. 0.0821 is constant, so not a candidate. And then 4.00 is not also a candidate because your molar mass is a constant value found in your periodic table. So our final answer should have 2 significant figure. Thus, the answer here is 0.69 atmosphere. Okay? Okay, so that is how we apply some of the equations or the equations derived from your ideal gas equation, PV is equal to nRT. Okay, so this is actually the solution from the PowerPoint. So I actually have the same equation, P is equal to dRT over M, and then I have also the same solution, but with the PowerPoint it has 300.15, so I think 27 degrees Celsius was added with 273.15 instead of just adding 273, but nonetheless, in our context, let us use just 273. And then they have 0.69 atmosphere, again having a different significant figure, but this should have been 0.69, following least significant figure among the given being 2 sig big. But nonetheless, it has the same process, it has the same procedure on how it was answered, and has the same values as well, 0.69 atmosphere. Okay, so I hope you learned a thing or two on how we can apply some of the equations derived from the ideal gas equation, which is PV is equal to nRT. Okay? Okay. Next bit is your combined gas law. Now, what about the combined gas law? The combined gas law is simply the combination, as the name suggests, of Boyle's, Charles, and Gay-Lussac's. This is an equation that shows the relationship between pressure, volume, and temperature at constant number of moles. So we have this equation. P1V1 all over T1 is equal to P2V2 all over T sub 2. Okay? So your Boyle's law is actually this one. And then your Charles law, that is your volume and temperature, if I'm not mistaken. Okay, if I'm not mistaken, I think that's your volume and temperature. Let me just recheck. Yeah, volume and temperature for Charles. So your Charles law is this one. And then your Gay-Lussac's. Okay, just change this one. Then your Gay-Lussac's law is your P1 over T1 is equal to P2 T2. So all of these particular gas laws were combined to form the combined gas law, which is P1V1 over T1 is equal to P2V2 all over T sub 2. Okay? So this is our main equation for the combined gas law. Example. Okay? A sample of sulfur dioxide occupies a volume of 652 milliliters at 40.0 degrees Celsius and 720 atmosphere. What volume in liters will the sulfur dioxide occupy at STP? So let me write the given. So given are volume 1, that is 652 milliliters. Then you have here temperature 1, that is 40.0 degrees Celsius. And then T sub 1, you have here 720 point atmosphere. Okay? And then required are your volume in liters. Okay? And then you have here, remembering that the given or the problem is under STP, then equation. Equation is P1 V1 all over T1 is equal to P2 V2 all over T sub 2. Okay? Now, since we need to solve for, so V sub 2, so V sub 2 is the one that we, sorry about that, V sub 2 is the one that we need to solve for, V sub 2. We'll derive an equation for V sub 2 by simply, first is cross multiplying your equation. So we have P1 V1 T sub 2 is equal to P2 V2 multiplied by T sub 1. Okay? So solve for V sub 2. Okay? For that equation, so divide both sides by P2 T1. Cancel, cancel, we shall have V sub 2 is equal to P1 V1 T2 all over P sub 2 T sub 1. Okay? So that will be the equation for your V sub 2. So double check if all are given or are provided. V sub 1 is already provided, T sub 1 is already provided, and T sub 1 is already provided. However, we are missing the given T sub 2 and then T sub 2. Okay? Now, how will we proceed? Wag pong kabahan or do not be anxious because since the problem mentions that the problem is under STP, meaning to say your P sub 2, okay, remember, the STP value for pressure is 1 atmosphere. So you can have a given. And then your temperature, since absolute temperature, we shall write 273 Kelvin. Ulitin ko po, bakit biglang nagkaroon ng mga given? Wala naman nabanggit na 1 atmosphere or 273 Kelvin dyan. Kasi nga po, nasabing under STP. Kapag napansin mo po na parang seemingly kulang, bakit kulang yung mga given? Paano ko masasagutan to combined gas law? Example, nandyan si V sub 1. Nandyan si T sub 1 nabigay. Nabigay rin si P sub 1. Pero bakit walang T sub 2 at P sub 2 dito sa problem? Huwag po kabahan, kapag nabanggit po na sa word problem na under STP, automatic po yung mga kulang na given like P sub 2 and T sub 2 will assume the values of their respective STP. So for P sub 2, since this is pressure, it will assume 1 atmosphere. T sub 2, since this is temperature, it will assume 273 Kelvin for temperature. Okay? Basta nabanggit na nag-occupy or under STP conditions yung gas at focus. Okay? So all of the values or factors are already provided. You may now proceed with your solution. Okay? But I almost forgot. Your T1 is still in degrees Celsius. We need to add 273 for it to be turned into Kelvin. Because remember, our temperature should always be in Kelvin to follow absolute temperature. So this is 313 Kelvin. Okay? So now we now proceed. P sub 2 is equal to P sub 1. My P sub 1 is 720 point atmosphere multiplied by volume. My volume 1 is 652 milliliters. And then my T sub 2 is 273 Kelvin all over P sub 2. That is 1 atmosphere multiplied by T sub 1, 313 Kelvin. So double check. P sub 1, your P sub 1 according to the equation, P sub 1 is 720. So correct. V sub 1, that's only volume, 652. And then T sub 2, final temperature, 273 Kelvin. And then your P sub 2, second pressure, 1 atmosphere. And then T sub 1, you have 313 Kelvin. Okay, so I have written the correct factors. So input in the calculator, 720 point times 652 times 273 all over 1 times 313. So we have this particular value. Okay, so let me just write it down. 409,447.6677. So cancel the units that are possible to be canceled. Atmosphere, Kelvin, we shall have milliliter. But then again, the problem mentioned that we need the unit liter. So we need to convert milliliter to liter. So we just simply use the conversion factor. Okay, so that is 1 liter is equal to 1000 milliliter. Milliliter will be cancelled. I shall have the unit liter. So this particular value, I just need to divide it by 1000. I shall have this answer. Okay. Now looking back at your given to follow correct significant figure. Now these are the only givens that I will be basing upon for my sig fig because your P sub 2 and T sub 2 came from STP, so they are not candidates. So this is 3 sig fig, this is 3 sig fig, and then 720 point is 3 sig fig. So I shall get 3 significant figure. The final answer is 409 at 409 liters. Okay? Okay. So I hope the application for the combined gas law is easily understood and you learned a thing or two. Okay? Okay. Now we are now on the last bit of our discussion, which is all about Dalton's law of partial pressures. Now what about this one? John Dalton established a law governing the pressures for mixtures of gases. The law is known as the law of partial pressures, and it states that the total pressure of a mixture of gases in a container is equal to the sum of the partial pressures of the gases. Sa madaling salita po, lahat po ng pressure ng mga gases or lahat ng pressure po ng individual gases sa loob ng mixture ay i-add lang natin. So yung mga pressure ng mga gases na pinagsama-sama sa isang lalagyanan ay i-add po natin yung pressure nila. So you have here pressure total is equal to pressure 1, pressure 2, pressure 3. So each pressure value or each values of this pressure, P sub 1, P sub 2, P sub 3, represents a pressure for a particular gas substance. Okay? So parang ang idea po ni Dalton's law of partial pressure ay pressure ni substance A, pressure ni substance B, pressure ni substance C, pagsasama-samahin or i-add natin. Okay, so that yet again, let me repeat, Dalton's law of partial pressure simply would like to say that, for example, meron ka na lagyanan, naglagay ka sa container na yun ng tatlong uri ng gases, gas A, B, and C. Si gas A may sariling pressure, so P sub A. Si gas B, meron siyang sariling pressure, P sub B. Meron ding gas pressure, si gas C, so meron siyang P sub C. So, si P sub A, P sub B, P sub C, i-add natin yung lahat. That indicates the P subtotal of those gases inside that container. Okay? Okay. Now, this will be the equation. For a mixture of gases, should we be depending on the nature of the gas molecule? This is the given formula. You have here, partial pressure is equal to mole fraction times total pressure. So we still have total pressure. Wherein your mole fraction is equal to N sub I. So this indicates the substance at hand all over total number of moles of your gases. Okay? So you have here the main equation. This is P sub A. A represents, okay? Your A here at P sub A represents the gas that is of focus. And then your X sub I is your mole fraction given with the equation X sub I is equal to N sub I all over N subtotal. Now the I here, the subscript, represents again the gas at hand that you are focused with. And then P sub T is the total pressure of all the pressures of the gas molecules. Let me provide an example on how to apply this particular bit. A mixture of gases contains 0.31 mole of methane and 0.25 mole of C2H6. The total pressure is 1.20 atmosphere. Calculate the partial pressures of the gases. Okay? Now, looking at the problem, the mixture of gases ay gawa po or binubuo ng dalawa. CH4 at C2H6. So, ilan? Dalawa. Isang CH4, isang C2H6. Ibig sabihin po niyan, kung pinapasolve o pinapakalculate ang partial pressure ng lahat ng gases, ibig sabihin, kung gaano man kadami ang gases na pinapasolve dyan, ganun din kadami kang magsasolve ng paulit-ulit nitong P sub A. So, ibig sabihin, magsasolve ka ngayon ng P sub CH4 and P sub C2H6. So, dahil dadalawa lang naman yung gases na nandyan, dalawang beses tayo magsasolve nitong partial pressure nila. Kasi yun sabi ng instruction, no? Calculate the partial pressure of the gases. Ilan yung gases mo dyan? CH4 at C2H6. So, mag-solve ka ng dalawang beses. So, ibig sabihin, kung mayroong mga tanong o exercises na mayroong 5 o higit pang gases sa mixture na yon, 5 o higit ka pang beses mag-solve ng partial pressure kung pinapahanap lahat. Pero kung pinapahanap lang naman ay pili, edi ganun din kadami yung hahanapin mo. Okay? Pero sa konteksto ng tanong na ito, lahat ay pinapahanap. Ang lahat na yun ay dadalawa, CH4 at C2H6. Okay? So let me solve. You're given R, so P sub T, your total pressure is already provided, 1.20 atmosphere. Okay? And then you have here the number of moles of CH4, N sub CH4, 0.31 mole, and then N sub C2H6, that is 0.25 mole. Okay, ito po yung mga Ni, di ba? Ito po, itong sinusulat ko ngayon na N sub CH4, N sub C2H6. Yan po yung N sub I. Ayan po, ayan sila. NCH4 and C2H6, sila po yung N sub I. Okay, sige, try natin ngayong isolve. So your required here is partial pressure of CH4 and partial pressure of C2H6. Okay, so dalawang beses mag-solve. And then the equation, okay, I won't be writing that one because that's long. But then again, let me just write the general formula. You have here P sub A is equal to mole fraction times total pressure. Okay, so solution. So first bit is that isolve ko po itong P sub CH4. Okay? So, following this format, X sub I, so that is the mole fraction. Remember, yung mole fraction is N sub I all over N sub total. So, ang ilalagay ko dito, N sub CH4 all over N sub total. Sorry about that. Let me write that one again. So, N sub total. So, X sub I times P sub T. Okay, so again, I just substituted X sub I with this one because X sub I is equal to N sub I all over N sub total. Okay, so this will be my format for P sub CH4. So ngayon, gagawin ko, substitute lang, N sub CH4, 0.31 mole all over N total. Ano po yung N total? Yung N sub total ay i-add po natin si 0.31 mole plus ito pong 0.25 mole ni C2H6. Bakit? Ibig sabihin po kasi ng N total ay total number of moles. So, ibig sabihin, yung summation nitong NCH4 at NC2H6. Okay? And then, multiplied by your P sub T, my P sub T is 1.20 atmosphere provided. So, let us just simplify the expression. So, 0.31 moles all over 0.56 mole multiplied by 1.20 atmosphere. So mole will be cancelled. The unit remaining is atmosphere. Okay? So before we solve for that one, okay, let me just input that in the calculator. 0.31 all over 0.31 all over 0.56 times 1.20. Okay? Following correct significant figure, so the least sig fig among the given is 2. Because this is 2 sig fig, this is 3. So 2 significant figure, 0.66 atmosphere for PCH4. Okay? Next, now that I've solved for PCH4, I may now proceed with the second one. That is partial pressure of C2H6. So again, same format. We have here mole fraction of C2H6 times P sub T. So changing the format, we have N sub C2H6 all over N sub total times P sub T. So N C2H6 is 0.25 moles plus the N total. My N total a while ago is 0.56 multiply by P sub T, 1.20 atmosphere. Cancel, cancel. I have atmosphere. Input in the calculator, 0.25 all over 0.56 times 1.20. Again, following two significant figures, just like a while ago, 0.54 atmosphere. C2 H6. So therefore, my final answers are partial pressure CH4 is 0.66 atmosphere and the partial pressure of C2H6 is 0.54 atmosphere. Okay, so I have actually the same solution with that of the PowerPoint, and also I have the same answer. For PCH4, 0.66. For partial pressure C2H6, I have 0.54 atmosphere as well. Okay? Okay. I hope you learned a thing or two on this particular topic, or actually for specifically for the second installment for the topics on gases. Okay. Now, apart from learning a thing or two, I hope you understood how the ideal gas equation, the Dalton's law of partial pressure, and at the same time the combined gas law equations are applied on their specific word problems. Okay. So again, I hope you learned a thing or two, and may everyone have a great day.